Let's do some more word problems. And this first one's a bit of a classic. Britt has $2.25 in nickels and dimes. If she has 40 coins in total, how many of each coin does she have? So let's define some variables here. Let's let n equal the number of nickels she has. Number of nickels. And let d is equal to the number of dimes. The number of dimes she has. So let's see. The first thing we know is that she has $2.25 in nickel and dime. So how much money does she have? Well, if you take the number of nickels, each nickel is worth 5 cents. So the number of nickels times 0.5, 0.05, that's how much money her nickels represent, plus the amount of money her dimes represent. So she's got d dimes. They're each worth 0.1 of a dollar, or 0.10, or 0.10 if we want to put the 0 in front of the decimal. So this is the total amount of money she has, right? If she has 5 nickels, you do 5 times 5 cents, it would be 25 cents. If she had 4 dimes, that'd be 40 cents, and you would add it all together. Now the problem tells us that the total amount of money she has is $2.25. $2.25. So this first statement right there can be translated into this equation right here. She has a certain number of nickels and a certain number of dimes. You multiply 5 cents times the nickels plus 10 cents times the number of dimes, you end up with 225. Now, this second statement, she has 40 coins in total. And I'm assuming that she only has nickels and dimes, that there aren't any other coins. So if 40 coins in total, that means that the number of nickels plus the number of dimes has to be equal to 40. So the nickels plus the dimes has got to be equal to 40. That's what that information tells us. Now we have two equations with two unknowns. And there's two ways we can do this. We can do this as a system, and we can subtract one equation from the other. Or we can do substitution. Let's do substitution. That's often a more intuitive way to do it. So what I'm going to do is I'm going to solve for, I could solve for either one. But I want to solve for, I'll solve for d, and then I'll substitute whatever I get for the d in this equation right here. So if we subtract n from both sides of this equation, so let me do that. Negative n plus this minus n. Obviously, these cancel out, and you're just left with d is equal to 40 minus n. Now, we can take this. We just established using the second equation, using this second statement, that d is equal to 40 minus the number of nickels. And we can use that to substitute back in for d. So this first equation will now become 0.05 times our number of nickels plus 0. I'll just write 0.1 times our number of dimes. But we already know the number of dimes is equal to 40 minus n. That's what that second statement told us. So instead of d, I'm going to substitute it with 40 minus n. 40, that's the number of dimes we have. It's 40 minus the number of nickels. And that is equal to $2.25. And now we can just try to solve for n. So we get 0.05 n plus 0.1 times 40. That is 4. Let me show you that I'm distributing it. So 0.1 times 40, that is 4, minus 0.1 n. I just distribute this times each of these terms, is equal to $2.25. And then what can we do? Well, we can, let's see, we can take 0.05 minus 0.1. That's or your 0.10, depending how you want to do it. If you take those two terms, you're actually going to get a negative 0.05 n, right? 0.05 minus 0.10. This is twice as big as that. So it's going to get a negative number plus 4. So I still have that 4 is equal to $2.25. Now I can subtract 4 from both sides of this equation. I get negative 0.05 n is equal to, if you subtract 4 from the left, that 4 is going to go away. You subtract 4 over here. 225 minus 4, that's negative 1.75. Right? All right, now we can multiply both sides of this equation by -1 just to make it a little bit cleaner. So that becomes a plus and a plus. And then divide both sides by 0.05. I could have just divided both sides by -0.05 to begin with, but I like getting everything positive. So if you divide it by 0.05, you divide by 0.05, you get n is equal to $1.75 divided by 0.05. So let's do this division. Let me do it in a different color. 0.05 divided into $1.75. Let's multiply both the divisor and the dividend by 100. So we're going to go over 2 decimal spaces. So this just becomes a 5. This becomes 175. This is the same thing as 175 divided by 5. 5 goes into 17 3 times. 3 times 5 is 15. 17 minus 15 is 2. Bring down the 5. 25. 5 goes into 25 5 times. 5 times 5 is 25. You have no remainder. So this is equal to 35. So n is equal to 35. Now we could solve for d. d is equal to 40 minus n. So d is equal to 40 minus 35, which is equal to 5. So we have 5 dimes. We have 5 dimes and 35 nickels. And just to verify that that actually does make sense, 35 nickels are going to be worth how much? Well, 35 times 5 cents is going to get us to 175 cents, or $1.75. So this times 35, that is going to be $1.75 in nickels, right? 35 times 5, or times 0.05, depending on how you view it. And then this is going to be 5. So this is right here is going to be 50 cents in dimes. $1.75 plus 50 cents, that's $2.25. Let's do one more. A pattern of squares is out together. Oh, let's see, a pattern of squares is out together as shown. I guess they're hanging out. How many squares are in the 12th diagram? So let's see what's happening. So this is the first. That is the second. That is the third. Let's see here. Each side, this is a 1 by 1 square. And then here it's 2 by 2, but then they take out this block right over there. So let's see. So one way you could think about it is, see, this is 2 by 2. Now this is a 3 by 3, but they took out the 2 by 2. And so the next one is going to be a 4 by 4. It's going to be a 4 by 4 where they took out the 3 by 3. So I guess one way that we can describe the number of squares, actually the easiest way, you don't have to think about that, is, look, I have 3 here, and then I have 3 minus 1 over here. Let me do that in a different color, right? 3 minus 1 over here. Here I have 2, and here I have 2 minus 1. And then here I have 1, and then I have 1 minus 1. I have nothing. So in general, the number of squares, if for any n, is going to be, it's going to be n plus, right, n plus, then we have n minus 1, plus n minus 1, which is the same thing as 2n minus 1. And it works, right? 2n minus 1. 2 times 3 minus 1 is 5. 1, 2, 3, 4, 5. So it works for these three. So the 12th square, so when n is equal to 12, it's going to be 2 times 12 minus 1, which is equal to 24 minus 1, which is equal to 23 squares in the 12th diagram. Actually, I said let's do only one more. Let's do another one. And we're in the zone. Grace starts biking at 12 miles per hour. 1 hour later, Dan starts biking at 15 miles per hour, following the same route. How long will it take him to catch up with Grace? So let t equal time Grace. The time Grace is biking. Actually, let me do it this way. Let me do it. The time Dan is biking. Then how long will Grace be biking? Well, he starts an hour let's see, did I say? Yeah, an hour later he starts. So whatever number this is, Grace is going to be biking for 1 more hour. So t plus 1 is equal to time Grace is biking. Right? When this is 0, this is going to be 1. She would have already been biking for 1 hour. And we just have to remember that distance is equal to rate times time. So Dan's distance is going to be equal to 15 miles an hour. 15 miles an hour times the time in hours. This is Dan's distance. And then Grace's distance, maybe I'll call that G. Well, or let's say D for Grace. That's her distance as well. That's her distance is going to be equal to 12 miles an hour. And her time, in terms of t, is going to be t plus 1. She's going to always be traveling for 1 more hour than Dan. So 12 times t plus 1. And the point at which they catch up, that's the point at which these two things are going to be equal to. That Dan's distance is going to be equal to Grace's distance. So we just have to set these two to be equal to each other. So you get 15t is going to be equal to, that is how far Dan has been riding his bike. And then is going to be equal to 12 times t plus 1. That is how far Grace has ridden her bike. And remember, her time is always going to be 1 hour more than Dan's. So let's just solve for time. So we get 15t is equal to 12t plus 1. 12t plus 1. And then if we subtract 12t plus 12, I don't want to make a mistake there. If we subtract 12t from both sides, you get 3t is equal to 12. Divide both sides by 3. Let me scroll down a little bit. You get t is equal to 4. So when after 4 hours, after Dan has been riding for 4 hours, he will catch up with Grace. This is Dan. And if Dan's ridden for 4 hours, Grace has been riding for 6 hours. 6 hours is how far Grace has ridden for. And Dan, after 4 hours, 4 times 15, 4 times 15, he would have gone 60 miles. And Grace, after, sorry, there's one more. This isn't a 6. She goes 1 more hour than Dan. So it's 5. She's traveled for 5 hours. So Grace would have gone 5 hours at 12 miles an hour. And that, once again, is also 60 miles. So they meet at exactly the 60-mile mark.